So now we're going to continue with subtopic 1.2, resolution of forces. In this lesson, you should be able to describe resolution of forces and also to solve problems involving resultant force and resolution of forces. Now, before we continue, let's look at the definition of resolution of forces. Resolution of forces is the process of resolving a force into two components, x and y. Alright? Meaning we are going to resolve it into two components, horizontal component and vertical component. Let's look at this orange box here. We are going to apply a force to it, which is represented by this purple vector. Alright? And this force here, we can resolve it into two components, Fx and also Fy. Alright? We have to resolve it into two components. And given that the angle between F and Fx is theta. Now, how do we resolve this force? Alright, meaning to say how do we calculate the magnitude of our Fx and our Fy? To do that, we're going to apply these two formula here. Now, Fx is equal to F cos theta and Fy is equal to F sin theta. Now, you need to remember that theta has to be in between F and Fx. Alright? It has to be in between F and Fx. Now let's look at this example here. If you look at the figure here, you have an auntie mopping the floor where she applies a pushing force 60 degrees below horizontal of 32 Newton. Now this pushing force here, we can resolve it into two components, Fx and Fy. Alright? We can resolve it into two components, horizontal component Fx and also vertical component Fy. Now, let's calculate the magnitude of your Fx. Again, we're going to apply the formula for Fx, which is F cos theta. Remember, theta has to be in between Fx and F. Now we're going to substitute it. F is 32 and theta is 60. So my Fx is 32 cos 60. So that is equal to 16 Newton. Now we're going to find my Fy now. So Fy, the formula that we use is F sin theta. Again, theta has to be in between Fx and F. Alright, this is my F. And this would be my theta. So substitute your F as 32, your theta is as 60. So my Fy is equal to 32 sine 60 degree and that is equal to 27.7 Newton. Now, let's look at this example. Here I have a boy going down the slide and his weight is 300 Newton. The slide is at an angle of 50 degrees. So now we're going to resolve this weight. We're going to resolve it parallel to the slide and also perpendicular to the slide. The one that is parallel to my slide is my Fx and the one that is perpendicular to my slide is my Fy. So now we're going to resolve it. Again, we're going to apply the formula that we have learned. Fx equals to F cos theta where my F is 300 Newton. Now, what is my theta here? Remember, theta has to be in between F and Fx. So this is my force, all right, which is my weight. And my theta should be here, in between my F and my Fx. So this is 50 degree. This is 90 degree. So this here should be 40 degree. All right. So my F, I substitute it as 300. My theta is 40. So my Fx is equal to 300 cos 40 Newton, and that is equal to 229.8 Newton. Now let's calculate Fy. So my Fy is F sine theta. Again, theta has to be in between F and Fx. So my theta we're going to use is 40 degree. Substitute your F 300 Newton, your theta as 40. So my Fy is equal to 192.8 Newton. Alright, so now we're going to try to solve some problems. Now let's look at this example here. Figure 1.19 shows a wooden block being pulled by a force T that inclines at an angle of 30 degrees above the horizontal surface. My T is 36 Newton. My R, which is my normal reaction force, is 6 Newton. My weight is 24 Newton, and my Fr, which is my frictional force, is 20 Newton. Now, when we look at this diagram here, T is not parallel to the x-axis, and nor it is perpendicular to it. So we are going to resolve our T. Alright, we need to resolve our pulling force here. Again, we are going to apply the formula that we have learned before. Now, my T, we can resolve it into two, Tx and also Ty. The formula that we use to resolve Tx would be T cos theta. Alright, again, my theta has to be in between my T and my Tx. So my Tx is equal to 36 cos 30 degree, and that is equal to 31.2 Newton. Now let's calculate Ty. Ty, the formula that we use is T sine theta. So my Ty is equal to 18 Newton. Alright, my Tx is 31.2 and my Ty is 18. Now we are going to determine the magnitude and the direction of the resultant force acting on the block. When we want to calculate the resultant force acting on the block, we need to consider our Tx and our Ty that we have calculated previously. Now let's calculate resultant force along y direction. Alright, along y direction. So resultant force here is equal to 24 Newton plus negative 6 Newton or minus 6 Newton, since it is in opposite direction, and minus Ty. So that is equal to 24 minus 6 Newton minus 18 Newton. So my resultant force along y direction is 0 Newton. So now we're going to calculate the resultant force along x direction, meaning we are going to consider the forces along here, which is only my Tx to the right and my frictional force to the left. So to calculate resultant force along x direction, it is simply Tx minus 20 Newton. So that is equal to 31.2 Newton minus 20 Newton. So my resultant force along x direction is 11.2 Newton. Right. So now, since we have calculated the resultant force along y direction and also the resultant force along x direction, so now we're going to calculate the resultant force. So my resultant force on the block is 11.2 Newton to the right. Now, what is the acceleration of the block if its mass is 2.4 kg? So the resultant force on the block was 11.2 Newton to the right. To calculate our acceleration, we are simply going to use the formula that we have learned in Form 4, which was F equals to ma. So my F is 11.2 Newton. My mass is 2.4 kg, so my acceleration is 11.2 divided by 2.4, which is 4.67 meter per second square. Meaning the object will accelerate to the right with an acceleration of 4.67 meter per second square. Now let's look at this next example. Figure 1.2 here shows the free body diagram of a block sliding down a smooth inclined plane. Now, when it is mentioned in the question that the plane is smooth, it means, is there any frictional force? No. Alright, there's no frictional force. Right. So there's no frictional force if it says in the question that the inclined plane is smooth. Now our weight here, we can resolve it into two components, Wx and Wy. Alright, where my Wx is parallel to my inclined plane, and my Wy would be perpendicular to my plane. Right. Now we're going to resolve it, meaning we're going to apply our W sine theta and W cos theta. Right. Now remember, my theta has to be in between my Wx and my W, which is here. That is my theta. So what is my theta there? It is 30 degree. Alright. Here is 60 degree, and then if you extend this, here would be 90. So this would be 30 degree. So my Wx is equal to W cos theta. So that is equal to 24 cos 30, which is 20.8 Newton. And my Wy is 24 sine 30, and that is equal to 12 Newton. Right. Now, if you look at the diagram on the right here, what you are seeing now is my free body diagram. I have rotated it a bit so that I want my Wx is parallel to my x-axis and my Wy is parallel to my y-axis. Now we're going to calculate the resultant force on the block using this free body diagram here. All right? Okay. Remember, when you want to calculate the resultant force, you need to calculate the resultant force along x direction first and also along y direction. Now let's look at the resultant force along y direction first. Along y direction, we have Wy minus normal reaction. So that is equal to 12 Newton minus 12 Newton. So my resultant force along y direction is 0 Newton. Now what about resultant force along x direction? Correct, it is 20.8 Newton. Now that we have calculated resultant force along y and along x, we are going to calculate the resultant force, the total resultant force on the block. So my resultant force on the block is 20.8 Newton to the right. Okay, so now we're going to calculate the acceleration of the block if the mass is 2.4 kg. Again, we're going to apply the formula F equals to ma. Right? Substitute F, substitute M. So your A is equal to 8.66 meter per second square. Meaning my block is going to accelerate to the right with an acceleration of 8.66 meter per second square. Alright, so that's it for today's lesson. I want you to do homework, formative practice 1.2 in your textbook. Alright, I want you to try it. Now, before we finish the video, let's just summarize a little bit. Remember, if I were to have a force acting on an object, the force can be resolved into two components, Fx and also Fy. Now, what was the formula that we used to resolve it? Fx is equal to F cos theta and Fy is equal to F sin theta. Now, our theta again, it has to be in between F and Fx. Alright? If you are given this one here, let's just call it 90 minus theta. Right? If you are given 90 minus theta, then remember, you need to use theta, this theta, the one that is in between F and Fx. And then, when you want to calculate the acceleration of the object, we are going to use this formula, F equals to ma, where your F should be your resultant force. Then you can calculate your acceleration. Right? So that's it for today. Thank you.